Speed round, let's go, quick, boom! The continuous function f defined on the interval -4 to 3, the graph consists of 2 quarter circles and one line segment, as shown in the figure above. The g of x equals 1/2 x squared plus the interval from 0 to x of f of t dt. Good?
Yes.
Alright, gotta read that fast on the test, okay? Gotta save as much time, finish half the time. Okay? So we can look it over, take the test again. You're gonna take the test twice during that time period. Imagine how crazy.
I know, it makes you-
Just close it, close your eyes, and pretend you just woke up, open it, and do it all over again. Okay? Imagine hardcore. Alright, so this is the graph of f, and they're telling us g is represented by this function. So now we want g of 3. So now they changed it up and they added something in the front. Oh my god. 1/2 times 3 squared plus the integral from 0 to 3 of f of t. Okay, remember you're replacing x's because that's what that variable represents, or that number. So the outside's easy, that's 9/2, right? And to calculate this, we have the graph of it, so we can use the graph. We want to know from 0 to 3. So we want this space combined with this space. Sorry, my iPad seems to be making noise. App's gone free. You have that app? It's called App's Gone Free. It tells you which apps have gone free. Ah, makes sense. And they're like free for that day or for that time period. It's pretty good. You get some good apps. Perfect. So what would that area be there? That bounded space? 0, right? You can check, the base is 1.5, this base is also 1.5. The height is 3, the height is 3. So you know they have the same dimensions, so they're going to be equal. Just double check, okay? Because sometimes the pictures are not drawn to scale. So this ends up being 9/2. G of -4. That's going to be 1/2 times -4 squared plus the integral from 0 to -4 of f of t dt. So this will be positive 16/2, that's what? 8. What's the problem here though? Oh, so I'm going to change this to a minus the integral from -4 to 0 of that function. Okay, so now let's go from -4 to 0. What did they tell us this part was? It was a quarter of a circle, right? And they also said this was a quarter of a circle. They want to tell you that so you know that that's what it represents. So this one would be 1 pi divided by 4. Negative pi over 4. And then this one's going to be 1, 2, 3, so that's 9 pi over 4, right? Because it's only 1/4 of that circle. We want to combine those. So what's 9 pi over 4 minus pi over 4? 8 minus 9 pi over 4 minus pi over 4, that's 8 pi over 4, and 8 over 4 is 2. So we end up with 8 minus 2 pi. Too easy, Pablo? I'm sorry. The next one is asking for what? G prime. So let's find out the formula for that before we actually plug in the number. So what would G prime of x be? Derivative of the first part. That's the derivative of 1/2 x squared. Just x, right? 2 times that minus 1. Okay? Plus, what's the derivative of this integral? F of x times 1, right? We multiplied by the derivative of the limit. So now if I want g prime of 3, it's going to be 3 plus f of 3. What's f of 3 using the graph of f above? -3, so that gives me 0. Beautiful. This one wants g double prime. Now we gotta get the derivative of the first derivative. What's the derivative of x? 1 plus, what's the derivative of f?
F prime.
F prime of x. So now I want g double prime of 2, so 1 plus f prime at 2. So what's f prime at 2? If I go to 2 and I go down to the graph, is it just negative 1? No? That would be f of 2, right? I want f prime, so I want the slope of the tangent line, which would be this line here. So what does it seem to be? Let's see, we go 2 down, 1 to the side? Yeah. If you're not too sure, go from the point that's given to the other point that's given, right? And you'll see that it's negative 6 over 3, which gives me the negative what? 2 plus the 1. Easy? Okay? So they're not going to tell you that you need to use the second fundamental theorem of calculus. You need to know when to use it. When are we going to use it? Derivative of an integral. Okay? How do we use it? How do we use it? What do we do? Plug in the limit times the derivative of the limit. Right? Minus, plug in the other limit times the derivative of the other limit. Right? If one of the limits is a constant, you don't have to worry about that. If that constant is on the top, then swap them, right? And negate your integral, so you're ready to go. Sounds easy? All right. So you have your assignment.